Okay, good, so that the image contrast is basically improved, because you have a good amount of low value pixels, there's a good amount of high value pixels, you also have good distribution of pixels in the middle range. So the histogram of this, I mean the image of this will be much better compared to images of this type. For example, there are no images here, no pixels here, no pixels on the, so all pixels are around only one region. So look at this image. So it is linearly, there's a cumulative histogram of this, for example. So it's very highly linear. So it's okay. So uniform distribution is what is needed. So that is why people go for something called histogram equalization. So histogram not equalized. So when you can equalize the histogram, now how to equalize the histogram? You have to modify the pixel value here, and see to that these pixel values may occupy this range. Some of these pixel values occupy this range. Some of these pixel value occupy another range, so that you make the pixels available in all intensity values. So if you can modify something like this, you are actually going for a histogram equalization. For this, we have certain transforms to do this. So the input intensity is modified through certain transform to get a new intensity. So we do this by kind of an equalization, histogram equalization, or histogram specification. So we need a particular histogram that is needed. So you have to modify the frequencies or the probabilities of the pixels that are being seen in particular intensity level. So you have a reference histogram. So for example, look at this two images. This is a low contrast image, because all these object of interest is the background is almost occupying the same intensity. Now when you can bring out the objects with better intensity and the contrast is improved, then you get for example, from this kind of a histogram, you're getting into a histogram that is uniformly spread across all frequencies. So of course this cannot be done manually. For example, you can't take each pixel and do it, but you have to apply a global transform, like transform T of R. So we have to specify this transform. So such transforms are initially derived from the image itself. So those are certain for example calculations of certain cumulative histograms, and then try to equalize them, right? So okay, so I think I'm probably coming to the end of the few parts of the portions. I have one more part. If you are interested, I will go through.